So just by a quick show of hands, who here have seen the Too Many Cooks video? We've got that's a good enough percentage for now. So we're just gonna hit it off.
It takes a lot to make a stew.
A pinch of salt and laughter too.
A scoop of kids to add the spice.
A dash of love to make it nice. And you've got
Too many cooks.
too many cooks.
Too many cooks. Too many cooks.
Too many cooks.
Too many cooks.
It takes a lot to make a stew.
When it comes to me and you,
And him and her and the baby too. Too many cooks, it's true.
you say it goes, it'll spoil the broth.
Honey, I think that's not true.
Well, maybe too many cooks will spoil the broth, but they'll fill our hearts with so much love. Too many cooks. A family is like a soup.
Everyone adds an extra scoop.
Mix an ounce of a smile so sweet.
A dash of cool to add the heat. And you've got
Too many cooks.
too many cooks.
Too many cooks. Too many cooks. Too many cooks. Too many cooks. Too many cooks.
Too many cooks.
Too many cooks.
Too many
All right.
cooks.
Too many
So, for those of you who have no idea what you just saw, Too Many Cooks is a TV skit that went viral a few months ago. And we liked it. You should watch it if you haven't. So if you've seen it, you can enjoy some references throughout this presentation. So if you haven't, then you can just laugh at the funny pictures. Okay, so who are we? So we're the Malware and Vulnerability Research Group at Check Point. What do we do here? We have this marketing slogan that says we secure the internet, and we actually try to do that by finding problems, telling the vendors, and sharing them with the community, which is exactly what we're trying to do here. So let's talk about what's in store for today. We're going to very quickly go through what TR69 is and explain a little of what we talked about last DEF CON, which will lead us to the motivation behind the research that we're presenting today. We'll talk about the TR69 Census 2014. We'll give you the interesting bits of our research story and some technical details. Then we'll continue to show what can only be described as mass ponage, and then conclude talking about why this won't go away so quickly. So TR69, TR is actually like an RFC, right? TR stands for Technical Report, and this is Technical Report number 69. And this defines the CPE WAN management protocol, which is CPE is a consumer premises equipment. That would be the home routers that you have at home. And this was released in 2004 by the Broadband Forum, which is a group of companies working to define broadband standards. And then there were a few amendments so far, but still remember that this was released just 10 years ago. And this is what ISPs use to provision your device. This is what's called the zero-touch configuration. It's used to monitor your device for faults or malicious activity and configure anything they want in your home routers, including getting your MAC addresses and host names for anything on your network, creating additional Wi-Fi networks, and go as far as deploying new firmware. So this is how TR69 sessions or provisioning sessions look like. So on the right side, we have the CPE, right? The consumer premises equipment, the TR69 client, that would be your home router. On the left side, we have the TR69 server, which is called an ACS, or an auto configuration server. And they talk in basic SOAP RPC, which is XML over HTTP. And it's important to mention that the client always initiates the connection, which is a single TCP connection over which RPCs are called back and forth. So the client begins with an inform telling the server why this session was initiated. And the ACS follows with provisioning functions such as get parameter values and set parameter values. It's pretty simple when you think about it. So there is a dual authentication mechanism that the CPE should make sure that it's talking to a verified ACS, and the ACS should only accept sessions from authenticated CPEs. And now there's a slight thing called a connection request that the ACS can issue, and we'll talk about that. So talking about our finding so far, we presented this at DEF CON 22. Our research uncovered implementation and configuration flaws in many ISPs' ACS deployments. So ACSs are a single point of ponage in modern ISP infrastructure. And many TR69 implementations just aren't serious enough. We found vulnerabilities in several products, and that leads to ISP fleet takeover. Exactly. So you remember that connection request thing? And this is straight from the TR69 specification. So the ACS can at any time request that the CPE initiate a connection to the ACS using the connection request notification mechanism. Support for this mechanism is required in a CPE, right? So straight from the specification. In fact, every TR69 client in the world is also a connection request server. On which port, you ask? And as it turns out, IANA assigned 7547 for all TR69 uses, and including the connection request port. And this is a widely used default. And let's look on some very interesting research released last year from the ZMAP guys, which is Zachary Rumerich and his friends from University of Michigan. And he's talking like in a couple hours. And they actually scanned 2 million random addresses on every port up to almost 10,000. And they found that CWMP, or the TR69 default port, is in fact the second most popular open port in the world, with 1.12% of the internet listening on that port. So again, this is for a protocol that was invented 10 years ago, so think about that. And you know how many devices are 1.12%, out of the public internet? This is around 45 million devices estimated that should listen on 7547. From a vulnerability research perspective, this is and no matter how hard we looked, no one is talking about this service, and there has to be something there. So let's review the top 2 open ports in the world. So previous research has given us this image. So in port 80, there are around 70 million devices, about 50% of which are web servers. It's regular web servers with Apache leading the bunch. You got your Nginx, your IIS, and then a small percentage for the rest, including Lightspeed and the Google dedicated servers. And the other 50% are simply those Internet of Things devices, right? Most of them are routers. You got your webcams, you got your voice over IP phones, and of course, let's not forget about all the IPv4 enabled toasters out there. So by the way, people start understanding that leaving these things open to the WAN is dangerous. Luckily, we're seeing more and more devices updated to have port 80 access on the LAN only. Now, remember that not only there is diversity in the server software, it's also being used for different uses, serving websites, all sorts of cloud services, and then management interfaces for each device. It's a messy landscape. But looking at port 7547, we have an estimated 45 million devices, and these are all Internet of Things devices, listening on their connection request port. There's nothing else there. It's just devices waiting for connection requests. So this landscape is much clearer. And remember, we're looking for security issues here. And we're looking to find significant numbers affected. So as a first step, we needed to stop guessing and estimating. So we conducted the TR69 Census 2014. And we scanned 7547 on the entire IPv4 address space. And we did this last month, a few times actually, with the gracious help of some good friends over at Rapid7 and University of Michigan who contributed to this research. So thanks, guys. And the results are 1.18% of the public internet responds on port 7547. So we actually communicated with 46,093,733 devices who answered our benign requests for get/. So these are all over the world, and it's not just one country who accidentally left this port open. It's 189 countries, which makes sense when you remember it's a protocol requirement to leave this port open for the ACS. And just a small note that the 0.06% increase from last year is actually 2.2 million devices added in a year, which is showing us a nice trend, and numbers are still on the rise. So we're set on finding an issue with TR69 client-side implementations. And the natural thing to do at this point is look at what implementations we're seeing out there. So we categorize the responses and sum up the numbers, and we get this. So we have 5 main connection request servers out there, but it's very clear that this thing called ROMPager, is leading the pack. And I think that means that we got ourselves a target. So what is ROMPager? It's an embedded HTTP server by Allegro Software. It's a Massachusetts-based company. It's optimized for minimal environments. It's a small binary, small memory requirements. It was first introduced in 1996. And there's been many versions since. The current version is 5.4. But then, now that we've decided that we're going after this ROMPager, we need to see what versions are out there. And this will help us focus our efforts. So we run the short script again, and we actually see just 4 different ROMPager versions out there. And you'd expect this sort of normal distribution of these versions in the wild, and instead we get this. So 98.04% of the identified devices are version 4.07, which is a pretty old version too. So, this is where I grew suspicious, right? I mean, what can explain this incredible popularity of a single version? Could it be like a batch of old devices at a single ISP or something? We just don't know it yet. And this really piques our interest, so we have to find out. So we went ahead and we bought a new TP-Link router, and we unbox it, we plug it in, we connect it to our network, and it's running ROMPager 407. So we thought, maybe this is an old version of the device. It has such like an old version of ROMPager. So we downloaded the latest firmware from the TP-Link website. We flash it, we reboot, and it's still ROMPager 407. So, I mean, what? At this point, we start understanding the popularity of the 407 version. I mean, we have no idea why it's there yet, but if it's somehow embedded into brand new devices off the shelf, with the most recent firmware, then that can certainly explain, why we're seeing so many of them. But let's try something here. Does anyone in the audience happen to have an unopened brand new router? Anyone? Oh, what a coincidence. What a coincidence. Thank you. Thank you, Virgin. Thank you very much. Oh, wow. Thank you, kind stranger. You're very nice. You don't work for me at all. So I'm going to do something with that later. Okay, so we dive into this ROMPager 407, and this was released 2002. So it seems to run a whole bunch of devices, and we return to our scan data and we start counting, and so we have 2.2 million devices serving ROMPager 07 on port 80, and 11.3 million devices on port 7547. And, suddenly we're like, wait, there are 12 million devices out there with this very specific version, of a web server that was released in 2002 listening on the WAN. Yeah, yes, this is the perfect vulnerability research candidate. And, zooming out for a moment, this is, to the best of our knowledge, the most popular specific version of any network application service currently available online on the public internet. This specific version is deployed on 200 different devices from 50 different brands. We are going to do whatever it takes to pwn Rompager 407. Let me hand it over to Lior.
Okay. So, hi, my name is Lior, and I will walk you through the process of how I analyzed the Rompager's firmware and some interesting results I found on the way. So, at the beginning, I only have the firmware file itself, which was downloaded from the vendor website. In our case, it was TP-Link. On first glance, the firmware file is looking like a big blob of compressed data. And as any rookie firmware analyst knows, the first thing you need to do is to binwalk your firmware. Binwalk is this great tool developed by DevTTY S0, which recognizes and unpacks most of the common firmware files. So luckily for us, binwalk easily recognized and extracted 4 files. So we have the bootloader, we have the vendor logo in the GIF images, and the main binary. So after I got the first firmware, I decided to download some more firmware which contained Rompager 407. So I downloaded some more, and some more, and some more, and I see that each and every one of them had the same ZenOS header and also the same architecture, which was MIPS. So while this Rompager 407 looks so similar, at this point I have no idea whatsoever. So one might ask himself, what is this ZenOS we are seeing in all the firmware? So ZenOS is an embedded OS created by Zixel, which is a major Taiwanese DSL vendor. ZenOS is an RTOS, a real-time OS, which means it's a very basic operating system without any file system or permissions mechanism. Just one big binary file responsible for everything. When you Google up ZenOS, you also see that ZenOS is very notoriously known for the ROM0 vulnerability discovered last year, which allowed an attacker to gain the router credentials by downloading the entire configuration file from the router without any authorization. All it takes is for the web panel to be open in port 80, and an attacker just simply gained the password and the username. And 1.2 million devices were affected by this vulnerability. Well, this is a lot. So before we start analyzing the firmware itself, let's see what our attack surface looks like. So in port 80, we are getting an unauthorized response, which asks us for the credential, and since we don't know them, we are getting this instead. In port 7547, we are getting object not found for any path except for the correct connection request path. For now, we assume that we don't know the correct path. So before I actually started to dive into the code, I did some basic fuzzing over the HTTP headers. Suddenly, I managed to crash the router by sending a digest username, by overflowing the digest username header, which led me to the first vulnerability. So to understand why this is happening, let's explore some of Rompager code. When you see, what you see here is a function responsible for initializing the HTTP handler structure. Each entry consists of the HTTP header name, as you can see here, and the relevant handler function to parse this header. So let's take a look on the function that parses the digest username. So can you see what caused the vulnerability? Yes, an unprotected strcpy. But what actually caused the router to crash, because we have no symbol and no dynamic analysis capability whatsoever, it's very difficult to know. So because I had no dynamic analysis capabilities, I open up the router and start looking for JTAG. So for those of you who don't know, JTAG is this interface designed to do hardware verification and debugging for embedded devices. So I opened up the router, but I couldn't find any JTAG connectors, but I did find something that looked like a serial port, a UART port. So I did some soldering and connected to the router itself and used Bus Pirate, which is a USB serial to USB adapter to connect it to my computer. And when I boot up the router, I could see some very nice debugging info. So it was very cool. But what happens when I try to crash the router? So this is what I got: a very nice looking crash dump with, you see here the MIPS registers and the stack dump, and also on the top you can see this one. This is the EPC, which is the MIPS instruction pointer. As you can see here, it was overwritten with my input. This means that we're actually in control of the instruction pointer. Yeah. So some further analysis of the crash dump allowed me to fully understand the vulnerability. So the strcpy caused us to overwrite a function pointer, which conveniently lays 584 hexabyte after the username. So exploiting this is pretty simple. Just send large username, override the function pointer with a pointer to your shellcode, and you can run remote code, and you have a remote code execution. So it sounds way too easy. Any problems? So yeah, we have a slight problem. Although all the vulnerable firmware are XenoOS based, each one looks a bit different in terms of memory layout. And it even changes between different firmware versions of the same model. This means we cannot know the correct position of our shellcode in the memory, and therefore we don't know with which value we need to overwrite the function pointer. Of course, if you knew the exact memory layout of your victim, you can easily run code on his router without any problem. It's also important to know that once an attacker has only one chance to attack a router, because if it causes a crash, then the router gets a new IP because of the dynamic IP allocation. So a potential solution for this whole problem would be just to find some infoleak vulnerability that would disclose the memory layout. But it seemed like way too much work for now, so let's keep looking for something else. So because I had no way of debugging, I had to use some very primitive debugging capabilities that were built into ROMPager, into the bootloader through the serial port, which allowed me to patch the firmware before it was being loaded. So it was very handy, but very tedious process. So after way too many hard resets, I found that there is a hidden telnet command in XenoOS, which lets you patch the router memory online. So this led to the creation of Zordon, which is a XenoOS remote debugger over the net. And with Zordon, you can set breakpoints, view and edit memory, and also read and write register value online. This made the dynamic analysis way more convenient. So using my brand new debugger, I was able to understand much better the nuts and bolts of ROMPager, which eventually led me to the second vulnerability. You see, ROMPager has no dynamic memory allocation capabilities. So each request is handled in a pre-allocated structure, without up to 3 requests handled at the same time. So if you send 3 consecutive requests, you can override the HTTP handler structure, which we saw earlier. This is also caused by an unprotected strcpy. So again, we can control over the EPC. So can it be exploited? Well, theoretically, you can blindly do a memory read of memory addresses by changing the pointer of some HTTP header name, but at the end, I decided to leave this vulnerability because it only works on port 80, and we already have ROM0 for that. So moving on to vulnerability number 3. So ROMPager supports cookies. Because ROMPager, as you remember, does not have any dynamic memory allocation, it's holds an internal cookies array for each request with up to 10 cookies at the array and up to 40 bytes long each cookie. the cookie names are constant. So it's C0, C9, C1, C2, up to C9. And the client, this is an example of a client sending one of these cookies. You can see here the C0 cookie. So let's take a look on the cookie handler to see how ROM-Pager actually store the cookies. So you can see here on the top that ROM-Pager checks the cookie name for a capital C at the beginning. If so, then it will convert the rest of the cookie name into an integer and use this integer as an index for the cookie array. Okay? So yeah, it will load it will multiply S3, which is the index, by 40, and then use it as a destination for the strncpy. Yep. So here you can see more easily. So basically, this gives me an arbitrary memory right from a relative position in the ROM-Pager internal structure, which means we can pretty much control everything ROM-Pager does. So a very nice bonus is that we can overflow the 32-bit integer to get to a negative offsets in the structure. So let's take a look on some non-harmful cookie. Instead of C0 or C1, we're sending this. With the index is pointing exactly at the request path field. We can see that we can now set this path to anything we like, and in this case, we'll get this. So we were able to overwrite the request path with our own input. But this actually has far worse consequences. So I'll need to mention this technique will work on any model, on any brand that we had legal access to. You see, with a few magic cookies added to your request, you can bypass authentication and browse the configuration interface as admin from any port. So to prove this insane claim, let's go straight to the demo. Sorry?
No, wait a sec. I'll fix it. Okay, 1 sec.
Go ahead.
Okay. Yes, we are ready. We are psyched. Next. Yes. Okay, so we actually have a video recorded, and then we're going to try the live demo. We prayed to the demo gods earlier, so hopefully things will work there as well. But first, let's look at the demo that will really, I think, explain the issue here. Right. So we enter the router. It shows us, username, password, login. We can also try to see what's available on 7547. Of course, we get the object not found. Then we use our Chrome plugin. And thank you. Thank you. Let's actually try this live and really hope that it works. Let's see now. We've got, all right, so we get the authentication required. Oh, you're not seeing that? Wait a sec. There you go. Well, it's a bit small, but still. So we're getting the authentication required. We're going to go to the misfortune cookie autoponer and try that again. See if it works. Hopefully it works. It doesn't. Oh, wait a sec. We're going to try that again. No, it's like an internal thing. Don't worry about it. Oh, it doesn't matter what port we are. Will this work? Yeah. Thank you. So again, you know, this is, you know, this is what we got at this store. This is brand new. This is a device that was manufactured 2014. This is very interesting. Okay, so back to our presentation. We set up this nice website, and it explains kind of the core issue here. And then we try to see which countries were affected by this. And, you know, again, this vulnerability affects devices in 189 countries all over the world. And in some countries, this is incredibly popular, affecting up to 50% of the IP addresses in use in that country. I'm not joking, that's 1 out of every 2 IP addresses in that country are vulnerable to this. And that's a few countries, and certainly some big names in the country list that you didn't expect to see there. Yeah, Smarf is happy about that as well. I know what you're thinking. I have to turn this off on my device right now. I should not have 7547 listening on my, on my public IP address. And as soon as you'll get home, you'll enter your configuration interface, and you'll find the CWMP settings, and you'll deactivate it. And you'll hit save. And it doesn't do anything because port 7547 is still open. That's right, there is no legitimate way for you to turn this off, even as admin. I don't know if to laugh or to cry, I don't know. So what can you do? You can cancel your internet subscription. Of course, I mean, the technical users, hopefully that's you guys, you can flash alternative firmware. So you have, both DDWRT and OpenWRT, which just don't have ROM pagers, so you can take your chances on whatever they have there. But it's not the old version of ROM pager. And don't buy these models until they're fixed. And the suspected vulnerable model list is on the website, and we occasionally update that. All right, so let's understand, the supply chain here. AllegroSoft provided ROM pager at one point to a certain chipset vendor. And this chipset vendor implemented the TR69 functionality and bundled this into their SDK as a bonus feature. Now, this SDK was provided to manufacturers who compiled their firmwares, for each product series and model. And just to make it a bit more complicated, the ISPs customized the firmware to include brand logos, default configurations, and deploy these versions to consumer devices. So you can start to understand this incredibly complex behind-the-scenes chain, and think about what this means for security updates, because the update propagation chain here is incredibly slow, if not non-existent. AllegroSoft has to provide a fixed version to the chipset vendor, which then has to incorporate this into the SDK, which has to be given to manufacturers who have to recompile firmwares for every product line and every product model, which have to give it to ISPs, which have to recompile it, to recompile the firmwares and the updated version using their customization. And now this thing has to be deployed on every device. This is a nightmare. And in this case, we can truly say that too many cooks do spoil the broth. And thank you. So, this is the good case we're describing here, because your device is controlled by your ISP. Because if you just bought your home router off the shelf, most people never upgrade their router firmware. And, anyway, this vulnerability will be here for months and years to come. So vendor communication. We contacted AllegroSoft and all the major affected vendors. We provided full description of the vulnerability and a non-harmful POC to trigger it. Despite some broken English, the message did get through. at least most of the time. We have some patched firmware already out, at least from Huawei, who actually they were the best responders so far. They have very clear communication. And Allegrosoft released a statement saying that we can't force any vendor to upgrade to the latest version, and we actually provided a patched version in 2005. So think about this: if code from 2005 still did not make it through the chain, and we actually know it did not make it even one step into the chain, something is wrong here. So just a few very frequently asked questions that we've been getting in the week that this is out. Is ROMPager bad? No. They were actually very responsive. They were security aware. They caught this bug in an internal code review. They just didn't know what it meant. When we explained it to them, they were, I heard the jaws drop over the phone line. And we just happened to research an old version of their software. I think it's any code written in 2002 might have been secured the same. And we don't think this is an intentionally placed backdoor. It doesn't look like one. We will not be sharing the exploit. No, I'm sorry about that. Some cert bodies have approached me, and they're asking about the IPs that are affected in their country, and I'm saying you have to scan it yourself. And listen, the numbers here are lying, because some ISPs actually don't use the default TR69 port. They use something else. I mean, at least we know that in Israel we use something else. And when you scan in these ports, you get very different numbers. So that's an important point to mention. Short recap. We found a pretty serious vulnerability in the most popular service exposed in IPv4. At least as far as we know. Do challenge us if you think otherwise. And hey, industry, fix this. Thank you very much. Would love to have your questions.
Well, thank you so much. Actually, I had the honor to mediate a similar lecture this morning at 11:30 by an Irishman who showed us that the switches that the main energy providers, actually you can just download the image and upload it when you've patched it into the ROM. This is a bit more complicated, but it's basically the same thing. Actually, it scares the shit out of me.
You should be scared.
Okay, we'll be taking questions.
Yes,
I can
please.
know, oopsla, that you guys want to know. So we'll do 1, 2, 1, 2. Is that okay with you? Okay, here you go. Number 1.
Okay, so I'd like to know a bit more about ZenOS, because at home I have...
Can you people please, when you leave quietly? Some people still want to listen. I'm sorry.
Yeah, so I have that D-Link DSL320B, which is in your list, and I started to poke into it because it's quite crap. And it runs the Linux, but it looks like before it runs the Linux, it runs something else, which has a drop bear. And I'd like to know if it matches ZenOS, if it's some kind of pre-Linux OS, or how does it work?
Okay, so first, we don't know that device because we don't have access to every single device that we saw on the list, right? We didn't try to exploit everything on the internet. Only devices that we could have legal access to we would love to talk about this later, and if you can share some details with us, then maybe we can look into this. But we don't have anything to add about this, I'm sorry.
Is it maybe compatible that the device starts ZenOS, which then starts Linux?
Do you know?
No, sorry, I don't know.
Okay.
We
thanks.
haven't seen this device, sorry.
Thank God.
Okay, thank you. There's somebody waiting at mic 2. Go ahead.
When you originally published this issue as Misfortune Cookie, you recommended to home users to install Zone Alarm as a protective measure on their end computers. Could you explain how installing a personal firewall would protect me from root opponents?
First of all, I can definitely explain how this helps if your router gets pwned, but it's definitely not what I want to talk about. And we can talk about this later if you'd like.
Okay, thank you.
Yes, more questions.
Okay. Next question, Mike 1.
You mentioned the affected IP address list for countries.
Please, can we have some quiet, please?
You mentioned getting the list of the affected IP addresses for a country. Just one request: please talk to the Shadow Server Foundation because they have the daily methods of scanning for exactly these kind of issues and send out the list of affected IP addresses to all national certs all over the world.
So I didn't
Please.
get the part you talking.
Shadow Server Foundation. We can talk later.
Okay, so talk to me later, sure. Yes, more questions.
Okay.
please.
We'll stick to the mic. No, there is nobody. Is there somebody over there? Oh, I come up front.
Oh,
Do I look that scary? Do they look that scary?
It's us, it's us.
I mean, to you folks. Okay, go ahead.
Did you? Thank you.
And speak into the mic, please.
Yes. Did you check cable modems? Because at least here in Germany, we are forced to use the modems we get by our providers, and especially models like the Technicolors are very well known for horrible exploits. Like you can force them to reboot with a broken HTTP GET, which is like kind of scary.
Yeah, so we didn't try to categorize according to cable or DSL or whatever it is. If it's on the suspected vulnerable model list, then we saw it as as vulnerable as containing ROM pager 407. That's a very simple check to make.
Okay, because I'm just asking because I have no possibility to switch as long as I stick to this ISP. So
I understand that. It's definitely a problem that we're seeing in other places worldwide. And, this is a part of why we're doing this, a part of why we're doing this publication. We think that this puts a very positive pressure on many, many vendors out there to fix this as fast as possible. We are seeing that this process is being expedited. So definitely in cases like this, if this is vulnerable, please go and talk to your providers and tell them this is a very, very serious security issue and you have to deal with this now.
Okay, thank you.
Thank you.
Okay, hang on a minute. We have a question from the internet.
Sure.
Because we've been streaming. So can we have a question from the internet, please?
Yes, there's a question. Have you tried to postpone GSOAP? If not, are you going to?
No, we did not try it. It's definitely a research direction. Anyone can take it up. We recommend that you do so.
Should I not do not request not?
We'll have one more question from the internet and then go back to Mike 1.
And wouldn't it be possible to use the exploit to exploit the router and then update them?
To exploit the what? I'm sorry.
To exploit the router and then update them using the exploit.
Oh, exploit the router and then upload. Yeah, okay. And then upload new firmware. Definitely.
Okay. Mike 1, I think, was it? Yeah.
Yep. Hi there. Yeah, very good talk. Thanks a lot.
Thank you.
So obviously the vendors are going to take a very long time to fix this, but is there any really legitimate use of this port 74547?
Yes.
From surely within the ISP's network, but over the network, is there any real use for this? Is this something that ISPs could, filter at their border, for example?
They use it all the time to do all sorts of monitoring and configuration issues. So if you block your 7547, if you magically block it somehow, right? Because a lot of the times you don't even have this option. But if you do block it, then they won't be able to help you with anything. They won't be able to see if anything's wrong with your device.
But is this something that ISPs can fix and stop the entire IPv4 space from?
Yeah, I mean, we released a protection white paper that's intended for providers, with some good advice on how to solve this. For example, just a real, a small taste of it. You could use an internal IP range to have this the 7547 listen on, and then you don't really have to put it on the public WAN. So that's, I mean, we're seeing some providers definitely do that, and that's a very good direction for Sol.
Okay, great. Thanks.
Okay, thank you. You queue up back. Mic number 2, your go.
Yeah.
Can we please have some peace? You want to chat? Okay, go outside.
If I can just respond to the previous question, I'm working for an ISP, and what you can actually do is just set an access list on those modems, so only the legitimate ACS can reach those modems. That's the simplest thing you can do as an ISP.
Yeah, I think we also mentioned that in the protection white paper, and thank you for that.
Second question is, are you aware of the research that was presented at Hack in the Box Amsterdam 2013 in April? Because I think they actually...
How I hacked your modem, yes.
Yeah, because I think they actually hit the same buffer overflow there.
Same buffer overflow?
No, it was a different version of ROMPager in a Zixel router, I think. It's a very... we are kind of the same, but it's very different vulnerability.
Okay, you checked. Okay, just wanted to know. Thanks.
Okay, thank you. Move over to mic 1. Talk into the mic. Talk into the mic. I have to record you for the stream.
Sorry. Have you looked into impact of what would happen if someone changed all the DNS settings of everyone's router to a fake DNS? Or changed everyone's SSID name and things like that? Or just generally played havoc with people's routers?
Well, definitely that's kind of what we're seeing in the past few years. Attackers doing in large, high-profile router attacks. They change the DNS settings, and it's pretty much game over from there. So definitely, that's also an opening for that. We really hope that attackers, don't get a hold of this, but it's definitely, I think it will happen eventually.
Thanks.
Okay, thank you. Here we go again.
I have several questions. So first question, which is support in Israel? So if I'm on holiday, maybe it's interesting. And so what's the support in Israel?
I'm sorry, again, the question?
The port for this thing in Israel.
Oh, the port in Israel. We can talk about that later. I don't want to give out, good details.
Okay, and then the second thing is, I, for example, have an evil ISP who gives me a Fritzbox, and the problem is that I cannot I cannot get my access data, and I cannot own this thing because I would then need to have a high-speed modem to go to the left side where it is connected to the fiber optic thing that generates this coax cable DSL stuff via maybe 20 meters. And so I need to do a sniffing device that goes there.
It's a real problem. We can understand that. It's definitely one of the things that make this issue so serious.
So how do I build a sniffing device? So is there maybe a device that I can exploit and say, okay, I buy a DSL modem and build a special sniffing, and so maybe a double modem device.
Yeah,
so
but then it's kind of, it's not going to be for the mass market. So
no, but I want to hack my Fritzbox, and then I know it, and then it's better for me. Then I can use something else.
I guess there are a few people here at 31C3 that could help you build that thing.
Okay. And then with cable modems, if you do it with cable modem, it would be much more fun because cable is flat. So even if I don't have subscribed to a cable device, I can just go into my flat, have a cable outlet, go to a flea market, buy a cable modem. I scan the internet for some cable modem in the city and dump the memory, put the access data of this person into my cable modem, and I can have it for free. How they catch me? It's flat. It's just passive networks like damping.
We're seeing a lot of these home router threats, and it's definitely one that we're also looking into, and the cable modems right now. So hopefully for next CCC.
Okay.
Right.
Okay, but we'll keep trying. Okay.
Yes.
Mic number 1.
Yeah. Is it correct that via TR69 the providers can also change this default port so that they can send you a new configuration?
Yes.
And so they could, on the very first provisioning of the box, when I just take it out and connect it to my DSL, that I get immediately from the ACS a new port, which is not the default port anymore?
Very possible and actually being done.
Okay. So then I would be vulnerable, of course,
on
if I have
the other
symbol,
port,
but
right?
on
So
the-
I mean, but we also recommended that some ISPs do that because at least you're going to get away from the opportunistic hackers that just scan the entire internet.
Okay.
I don't know who would do such a thing, but
Yeah. Maybe regarding your statistics, Germany was quite light colored. Is it because you've scanned only that port, or did you scan?
we only scanned 7547. It's important to mention all of our numbers are based on 7547. If you go into the depth of each country, of each ISP, you can potentially find a lot more vulnerable devices.
Okay, thank you very much.
Okay.
And if anyone does this, please do share it with us because we might make this public and help your provider fix this.
Okay. Now, you all people know that if you want to go back and look at this talk, you'll find it on the internet in our stream archive, just before you get panic. Number 2, please.
Okay, I didn't quite get how the protocol actually works. Why is the listening service on the client side actually required? Because you said every communication is initiated by the client, and why?
Yeah, well, first of all, you understand that this vulnerability has almost nothing to do with TR69, doesn't have anything to do with the protocol. It's just a web server that's listening on this port because of TR69. And so just mentioning again what I said at the beginning, that this is a connection request port that ACS can send connection requests to, which the client immediately follows by making a new connection and do a real provisioning session.
Okay, that's it. Okay.
Yeah, and this is XML over HTTP, so this is an HTTP server.
Okay, before they shut down the internet, there is this question.
Yes, from the internet.
Yes. What is with the newer versions? Are they really fixed?
The new versions have been fixed. We some vendors have provided us with beta versions of firmware, of fixed firmware, and they actually fixed it right. I mean, at least as we see it, they're checking it correctly, and they fixed the buffer overflows, and just patched it. Actually, on ROM pager 407, they just patched these vulnerabilities. So there might be more things there. And also, just an interesting point here, that would make it a bit difficult to understand if a device is now still vulnerable, because the server header is still going to be 4.07. And then you'd have to find like a different way of figuring out if this is vulnerable. Yes.
Okay. Some more? No child left behind. We answer all questions.
There are more questions. How about IPv6 devices using dual stack light?
I'm sorry, I didn't get the question.
How about IPv6 devices using dual stack light?
Dual stack? Oh, we did not look into that at all. Sorry.
Okay, that was it? Anybody else a question? You guys want to ask a question? No? Okay, well then let's have one big final hand. Thank you.